All right, guys, you ready for this? We're going to cover physical to virtual, or P2V. Let's get to it. Right, so gearing up for having a higher sense of agility in modern IT infrastructure, more and more IT owners now have shifted their traditional physical server-based data center to a virtualization-based one. So this goal cannot be accomplished without passing the process, namely P2V migration. So let's talk about P2V, physical to virtual, right? So it's a data migration approach that helps physical server users shift to virtualization. The operating system, or OS, and all upper-level applications in one physical server are the main objects of the migration, whose final destination would be the target virtual server managed by VMM, or Virtual Machine Monitor. P2V can often be realized with the help of specific tools and software by mirroring the system status and the data on the physical server to the virtual machine provided by VMM, and replacing the storage hardware and network hard driver of the physical server in the virtual machine. Now, as long as you correctly install the corresponding driver in the virtual server and configure the same address as the original physical server, such as your TCP/IP address, then the virtual server would be able to replace the physical server once it's rebooted. So people are going to choose P2V when the utilization of physical servers is very low. Converting them into virtual machines can greatly help improve the resource utilization rate. The software environment built upon physical servers is very complex. P2V does not require reconfiguration of the environment. Higher reliability of the IT system is needed. Snapshots and high availability can be achieved at the hypervisor level after conversion. Based on these three commonly seen scenarios, the reason why we're going to talk about the ways to realize migration today is clear. You agree? Yes? Of course. Let's have a look at the first method. So the manual migration method requires the migration operator to have a solid understanding of the physical system and the virtual environment. So first, shut down the services and operating system on the original physical machine, and start a new system from another medium, such as booting a new CD system from Live CD. Most distros have Live CD. Convert the disk of the physical machine system into a virtual machine image file. If there are multiple disks, you're going to need to make multiple images and copy the image to the virtual host. Then create a virtual device for the virtual machine. Load the image file to start the virtual machine, adjust any system settings, and start the service. Secondly, you've got a semi-automatic migration. You can use some professional tools that will help automate parts of the manual setting process, and this will assist you in P2V migration. So, for example, converting the disk data of a physical machine into a virtual machine format has always been kind of a time-consuming task. Here, you can then choose a professional tool to complete this step. So let's have a look at the commonly used P2V tools. Virt P2V, capable of converting a physical machine to run a virtualized on KVM, managed by libvirt, OpenStack, Ovirt, Red Hat Virtualization, sometimes known as RHV, or one of the other targets supported by Virt V2V, another tool that reads Linux and Windows guests running on other hypervisors and converts them to KVM. Disk2VHD. Now, this is a utility that creates a VHD, or virtual hard disk, Microsoft's virtual machine disk format. So these are going to be the versions of physical disks for use in Microsoft Virtual PC or Microsoft Hyper-V VMs. Now, there are tons of other tools available in the market, so it's better to make up your own mind by doing the research and then taking the desired virtual platform and the usability into consideration. So, unlike most P2V tools that only support cold migration, during the migration process, the physical server should be unavailable. Live migration refers to zero downtime when data is being migrated. Now, with the development of P2V technology, VMware vCenter Converter, as well as Microsoft Hyper-V, have been able to perform live migration capabilities to help avoid that downtime. So it's often used when business continuity is required, but a physical server is in need of update or maintenance. So yeah, we've got VMware Converter. This is the VMware standalone converter. It's now known as VMware vCenter Converter Standalone. So it's a tool used in VMware vSphere environments to convert physical and virtual machines to VMware virtual machines using the VMware Converter for P2V process. Now, you can always use VMware Converter to perform V2V, virtual to virtual conversions, in order to convert virtual machines running in one type of virtual environment to another virtual machine. But for the purposes of what we're doing, we're going to refer to it simply as VMware Converter. All right? Now, of course, it is a supported VMware tool. But you should note the last build of VMware Converter for P2V was released in 2018. Now, VMware has made no mention as of yet to deprecate the product, but there's really no comparable VMware tool used to perform similar conversions. So there we are. Now, you can use VMware Converter to perform a physical to virtual conversion of a powered-on local machine where VMware Converter is running, a remote Windows host, a remote Linux host, but you can also convert machines that are powered off in the following environments: VMware Infrastructure Virtual Machine, vSphere, VMware Workstation or other VMware virtual machine, Hyper-V Server. So you see, these options illustrate the difference between what is known as a hot clone versus what is known as a cold clone. Hot denotes the source machine for the VMware converter for P2V or V2V is powered on, whereas cold refers to a powered off machine. So now, when would you want to perform a cold clone versus a hot clone? Well, many server workstation types may do really well with a hot clone process, while the machine is in a powered-on state. The hot clone process may work fine if the source does not have dynamically changing data and is relatively static. However, workloads that house database applications are a much better fit for that cold clone process. It can, of course, be problematic with most database applications to have the database still running, servicing the application with data changing while running a hot clone. Right? In addition to that, the hot clone copy of the database server can have missing or corrupted data. The cold clone with the machine powered off ensures no changes are made to the database, so the new VM copy contains all the data without any chance of corruption. Have a look at the screenshot. You may notice here there is no cold or powered off option for physical Windows or Linux machines. See, many versions ago with VMware Converter, VMware made a cold clone CD available, and that allowed booting a live CD and running the conversion process on the workload. This CD or ISO is no longer available in the latest versions of VMware Converter, but an alternative to running a cold clone of a server workstation with database applications is just stopping all the database services and then making sure that all critical services are stopped before running a hot migration of the powered-on workload. Now, if you have an old workload circa Windows Server 2003, you can still find the old VMware cold clone CD floating around the web for download somewhere. Now, since hot cloning, also called live cloning, converts a source machine while the operating system is running, and processes continue to run on the source machine during a conversion, the resulting virtual machine is not going to be that exact copy of the source machine. But you already figured that out on your own. Now, like we were talking about before, stopping services helps to overcome many of the challenges associated with hot cloning. However, when cloning Windows machines, VMware Converter can perform this operation automatically and synchronize data between the source and the destination operating system using changed block synchronization. And this will ensure that data is an exact match before powering down the source machine. Copying changed blocks is used in many processes, actually, including storage migration and backups by third-party data protection solutions. You can find the settings of VMware Converter to stop selected Windows services so no critical changes occur on the source machine during the data synchronization process. VMware Converter can automatically shut down the source machine and power on the destination machine after completing the data synchronization process. Using this cloning automation provided by VMware Converter allows seamless conversion with little downtime of the workload. When the cloning process is complete, the newly created virtual machine is booted, taking over the identity of the source machine with the least possible downtime. All right, so let's have a look at this table here in front of you. So these are the data cloning operations that are supported by VMware Converter. Over here is the data copy method, the application, as well as a brief explanation. Right, so when it's volume-based, you copy volumes from the source machine to the destination machine. So basically, volume-based cloning can be slow. File-level cloning is slower than block-level cloning, but VMware Converter converts dynamic disks into basic volumes on the target virtual machine. When you move to disk-based, you create copies of the powered-off source machines for all types of basic and dynamic use. You cannot select, though, which data to copy, right? Disk-based cloning is a whole lot faster, though, than volume-based cloning. When you're talking about a linked clone, use this to check the compatibility of non-VMware images, and you can do that rather quickly. So the linked clone is corrupted for specific third-party sources if you power on the source machine after the conversion. See, linked cloning is the fastest, but it is incomplete as a cloning mode that VMware standalone converter supports. So we'll talk about more of that. When you install VMware Converter, you can choose between two different installation types, and these are a local installation. The local installation of VMware Converter installs Converter on a local machine only. But you can use this option to create and manage conversion tasks from the local machine that it's installed on, right? So, for example, you can install VMware Converter for P2V locally to process the local machine itself. Client-server installation, it's more advanced, but in the client-server installation, you can actually configure a client-server model for a converter to have a centralized approach to using VMware Converter across an environment where there's a centralized VMware Converter server that will provide conversion capabilities for its IT admins, right? Now, in addition to that, it also allows local and multiple remote clients to access the converter server. The client-server installation includes 3 different components for installation, which is also what makes it more complex. So you've got the converter server, right, which provides centralized management for all conversions. In addition, the converter server handles communication between clients as well as the converter agent. Converter agent, I'm glad you asked, allows a local machine to be a source for conversion. And then we've got the converter client, which connects to the converter server and provides a graphical user interface for setting up and managing conversions. Obviously, VMware Converter is quite the robust tool for performing standalone conversions from physical hardware to virtual machines or from virtual machines to other virtual machines. However, there are some typical use cases and those that are not so typical for using VMware Converter. So I want to tell you about a few of these. Some typical use cases would involve server consolidation, migrating from old server hardware, changing disk sizes, migrating from ESXi VM to VMware Workstation, and of course, migrating from VMware Workstation to ESXi VM. So, what are some of these non-typical use cases? Well, I'll also throw in a few that will not work. Cloning a domain controller. Now, this is something that's just frowned upon because it can cause some major issues, no matter what cloning tool you use. If applications depend on specific underlying hardware, serial numbers, and device manufacturers, for instance. Also, if applications depend on a specific MAC address. And cloning FAT32 volumes. Let's talk about some limitations between Windows and Linux hosts. So here you can see is Windows, and some of those limitations would be when you convert UEFI sources. Converted standalone does not copy any UEFI variables to the destination. Synchronization is supported only for volume-based cloning. And that's, of course, at the file level. With Linux, only volume-based cloning at the file level is supported. Of course, only managed destinations are supported. Converting multi-boot virtual machines is only supported if Grub is installed as the bootloader. Lilo is not supported. Converter standalone copies only the current UEFI boot entry option to the destination when you convert UEFI sources. Make sense? Now, simultaneous cloning of multiple disks and volumes is supported only when converting a virtual Linux source. And then installing VMware tools on Linux guest operating systems, guess what? Not supported. All right? So here we're going to examine the process of installing VMware Converter. It's basically a next finish process. So first, you'll just need to begin by downloading the latest version of VMware Converter. And you download the installer, run the exe file. After executing the installer, just click Next on the welcome screen. Now you got to accept the patent agreement and agree to the terms of the EULA and select the destination folder for the installation. Then you select the setup type for the installation, and finally choose between the local installation and the client-server installation for advanced setups. So for the demo in here, we're just going to be using the local installation of VMware Converter to showcase some functionality and features. Yeah, you have to opt in or opt out for the VMware CEIP program. And then finally, your VMware Converter installation will be ready to proceed. Okay, so just click Install to begin the installation of VMware Converter. Then after a short while, VMware Converter installation will show you, hey, we're ready to rock and roll. So after you click Finish, you can just choose to launch VMware Converter to begin your first P2V or V2V conversion. All right, so you ready for a walkthrough? Now we're going to walk through using VMware Converter to convert a running Windows host to a virtual machine. The source of the following walkthrough is a physical Windows Server machine that will target a VMware vSphere cluster environment. And this picture here, you can see that we're selecting a remote Windows machine. We're entering guest OS credentials to install the VMware Converter agent. And here you can select how you want the agent to be uninstalled once the conversion is complete. The default selection, of course, is to automatically uninstall the files when the import succeeds. So the VMware Converter will begin installing the agent on the remote Windows host. And select the destination type of the VMware Converter conversion. And you've got a couple of choices: VMware Infrastructure Virtual Machine, or VMware Workstation or other VMware Virtual Machine. Then enter your credentials that are needed to connect to that destination type selected in VMware Converter. And then the next step is to select the destination VM name and location. So this is not a rename of the guest operating system. This is the virtual machine inventory name. All right. Select from the available storage and select the virtual machine version. Now you see a few options on this screen, so you have the opportunity to configure the parameters for the conversion task. So this step allows you to change the resulting virtual machine's configuration to be different from the source, including data to copy, devices, networks, services, as well as some advanced options. And you can click the Edit link next to each section to change the configuration. And just click Finish on this summary screen to begin the conversion process using the famed VMware Converter. Now the conversion process begins, and it's going to display progress in the status column. I just want to make note here that the first conversion process failed for Windows Server 2019 host targeting a vSphere 7.0 Update 2 environment, because I left the default for the virtual machine version set to version 1.9. You see that? However, when converting the machine the second time, I did choose version 11, and the conversion process completed successfully. So it would seem that with this test, the newest virtual machine versions are actually too new for VMware Converter, targeting the most recent vSphere versions. But it's a simple workaround. Just choose a lower version. I chose version 11, and that was successful. Now, when you're running a Linux server, well, using VMware Converter is not that much different. So here, I just want you to notice that we select a remote Linux machine. Then you enter the connection information for the remote Linux server. You accept the certificate warning coming from the remote Linux server via the SSH connection. Note here, too, when you're using VMware Converter for the remote Linux host, we only have the option to target a VMware infrastructure server. If we select powered off, we can select other targets. All right. So we'll choose the virtual machine name for the vSphere inventory. Choose virtual machine storage for the resulting virtual machine. Now, once you're on the options page, you can edit the configuration options if it's needed for the Linux virtual machine. And then we can just begin the conversion process by clicking Finish. See, so VMware Converter is an excellent tool for converting both physical hosts and virtual machines. You can actually target a wide variety of environments with the tool, and it automates much of the process, making the conversion fairly seamless. As you might have seen, VMware Converter can both convert Windows and Linux hosts that are powered on, and can also convert virtual machines that are both powered off in VMware and Hyper-V environments. You just have to remember some of these prerequisites and use cases that are not going to work for you. Also, hopefully you understand by the conversion results, VMware Converter has not been updated in over 3 years, since that's 2018, it looks like here. So depending on the virtual machine version and some other configuration options that you select, it may or may not work without error targeting the newest VMware solutions, such as vSphere 7.0 Update 2 and higher. But, as I showed you as well, there's some pretty easy workarounds. So that's pretty cool, huh? We've learned all about physical to virtual, or P2V, and I'm sure you learned a lot, but guess what? There is more in store, so I'll see you in the next video.